Hello everyone, welcome to my YouTube channel. Today topic is Theory of black holes. A black hole is a region of space-time where gravity is so strong that nothing, not even light, can escape its pull. According to Einstein's theory of general relativity, this phenomenon occurs when a massive object collapses under its own gravity to a point of zero volume and infinite density, known as the singularity. The size of a black hole is characterized by its event horizon, which is the point of no return beyond which anything that enters the black hole cannot escape. The event horizon is defined by the Schwarzschild radius, which depends on the mass of the black hole. There are several types of black holes, including stellar black holes, intermediate black holes, and supermassive black holes. Stellar black holes are formed when a massive star runs out of fuel and collapses in on itself, while supermassive black holes are thought to exist at the centers of most galaxies, including our own Milky Way. The study of black holes has revealed many interesting phenomena, including Hawking radiation, which is a form of radiation emitted by black holes due to quantum mechanical effects, and black hole mergers, which occur when two black holes come together and merge into a larger black hole. The theory of black holes is still an active area of research, and there are many open questions and mysteries to be explored. Some of the biggest challenges include understanding the nature of the singularity at the center of black holes and reconciling general relativity with quantum mechanics in order to develop a unified theory of gravity. Black holes are fascinating objects that have captured the imagination of scientists and the public alike. Here are some additional details about the theory of black holes. One of the key predictions of general relativity regarding black holes is gravitational time dilation. This means that time passes more slowly in the strong gravitational field of a black hole compared to outside of it. This effect has been observed in experiments involving atomic clocks placed at different altitudes on Earth. Another consequence of general relativity is gravitational lensing, which occurs when the path of light is bent by the gravitational field of a massive object. Black holes can cause strong gravitational lensing, which has been observed in many astronomical observations. The study of black holes has also led to the development of new mathematical tools and techniques, such as the no-hair theorem, which states that black holes are characterized by only three parameters: mass, charge, and angular momentum. Black holes are not completely black. They can emit radiation through the process of Hawking radiation, which is due to quantum mechanical effects near the event horizon. This radiation causes black holes to slowly evaporate over time, eventually leading to their complete evaporation. Supermassive black holes are thought to play a crucial role in the evolution of galaxies. They can influence the orbits of nearby stars and gas, and may be responsible for the formation of some of the largest structures in the universe, such as galaxy clusters and superclusters. Black holes are not just theoretical objects. They have been directly observed through their effects on nearby matter. For example, astronomers have observed stars orbiting around a supermassive black hole at the center of the Milky Way, and have detected gravitational waves emitted by black hole mergers using gravitational wave detectors like LIGO and Virgo. Overall, the theory of black holes is a fascinating and active area of research, with many new discoveries and insights expected in the coming years. Thanks for watching video. Please subscribe this YouTube channel, Random Video House, and follow my Facebook page, AKN Goodbye.